You would think that why would they keep a night watchman? I don't know. But in the end, they let me go, and of course I was very happy, because this US is the best place to do physics.
You came to America. In 1 year you got a PhD, and then the next year you were at Tufts here as a faculty member. I'm wondering if here in America you have at all felt like an outsider to not only the country and the culture, but to the camp of physics, because specifically many of your ideas about cosmology have been way ahead of their time, and they were not accepted then. They were, as you mentioned earlier, laughed at occasionally, but now they are accepted. Is this an evolution that you have experienced?
Maybe since you mentioned it, I should comment on that. I certainly am an outsider to American culture, but I should say that I never expected such a friendly reception as I actually got in this country. I thought that I'll come to US and we'll start washing dishes and I'll look around and maybe at some point we'll start return back to physics. But I didn't feel that I was at any disadvantage at all, being a foreigner, being an immigrant. So it was wonderful in that regard. And people were extremely helpful and friendly. Now, in terms of being an outsider in physics, I think it helped that I worked, as a night watchman, and it helped to develop my kind of personal view of things. So everything, at least most things, have both pluses and minuses. And being out of physics, mainstream physics, had many minuses. This is probably one plus, that you develop maybe a unique perspective. These ideas initially were not well, I wouldn't say they were not well received. People thought they were cute, about the creation of the universe. One friend of mine, Lawrence Krauss, when he was at a talk, when I gave this talk at Harvard about the creation of the universe from nothing, and he came up to me after the talk and he said, "It's amazing to give a talk like that and survive."
But let me ask you, why is the idea that the universe was created from nothing such a controversial idea? Obviously, before something is created, there is nothing. I mean, just as a sort of an intellectual concept. What did they think was there before the creation of the universe?
Well, physicists kind of naturally think that the universe existed forever.
What about the Big Bang?
Big Bang was a big problem, actually, for many physicists. And before the ideas of Big Bang were developed, of course, everybody thought the universe is eternal. After that, people thought that this is just one of those questions you don't ask. What happened at the Big Bang? There is a mathematical singularity in the equations. You cannot extend the equations beyond that. So physicists were uncomfortable about this thing, but after a while they get used to the fact that this is not something you discuss. But of course, this is only true up to a point when you figure out the way to ask the right question. And physicists are very flexible that way. When they see that the issue can now be addressed, they turn around reasonably fast.
You're listening to ThoughtCast. I'm Jenny Attia, and I'm speaking with the physicist Alex Vilenkin. Alex, tell us about how it will all end. What do you think will happen?
Well, this issue has undergone some evolution. There are basically two possible ends for the universe, for our local part of the universe. None of them actually is particularly pleasant. One is that the universe will stop expanding and it starts contracting and will recollapse. As it starts collapsing, the temperature will rise and in the end everybody will fry. But by that time the stars will be long since dead, so probably we shouldn't worry about the details of this. And another possibility is that the universe will keep expanding forever, and in that case the temperature will go down and stars will die and everything will freeze. So it's fire or ice. But I think according to this picture of the multiverse, the answer is that it's going actually to end in fire. And it is because of the energy of the vacuum. The energy of the vacuum, as I mentioned, now it is very small, but it's positive number. But according to this theory, there is a whole range. There is a lot of states of the vacuum with higher vacuum energies and a lot of them with lower vacuum energies. When the energy is high, you have inflation, and the universe expands at a tremendous rate. But when the energy of vacuum is large and negative, the universe contracts at similarly tremendous rate and collapses.
And you said it's slightly positive.
Now it's slightly positive, but since there are lower energies, eventually we are going to get there. And our part of the universe is going to recollapse. But the entire universe will not end. So this is our local affair. Each part of the universe will go from inflation to a region like ours, or maybe somewhat different from ours because of different constants of nature. And in the end, it will end up collapsing to a big crunch.
Before that happens, though, you wrote in your book that our galaxy, the Milky Way, will most likely merge with the Andromeda Galaxy.
100%.
And after that, a bubble wall might smash into us, turning us all into alien particles.
That's true. This is the question of how do we get to this negative energy. And the most likely process is a bubble nucleation.
And what is that?
Well, it is like bubble in water. You know, when water boils, bubbles spontaneously form. But here in vacuum, the probability for bubble nucleation is extremely small. So it takes an enormous trillions and trillions of years for this bubble, and maybe a lot longer for a bubble to form. But once it forms, it expands at a speed close to the speed of light, so it hits you without warning.
And it's so fast that we don't know it's coming.
That's right. And once it hits us, we are inside this bubble, but inside that bubble, the particles we are made of now cannot exist. So it's some alien form of matter, so we will be totally annihilated. Unfortunately, well, this will probably happen, as I said, when we are no longer around, when the stars are dead and so forth.
Reincarnation. We will be transformed into alien particles.
That's true.
And then after that is the big crunch. Is that more or less the story?
Right. That's right.
Well, Alex Vilenkin, thank you very much.
It's a pleasure.
You've been listening to Thoughtcast. I'm Jenny Attia, and I've been speaking with the physicist Alex Vilenkin. Thanks for listening.